Hi again everybody. So this is the second video in my trigonometry revision series. As mentioned, a few people have asked for some help about how they read a question and create a diagram. They've also asked for some help about bearings and going back to the beginning. So this is our second video and the second question. These questions, they're not in any particular order. I haven't chosen easy questions first, so you will need to watch the whole series to get an idea. Don't stop on the first video thinking, nah, that's too hard, I give up. Maybe you can just watch the first video and listen, and then you'll come back to it later when you're feeling more confident. So let's jump straight into our second question. The second question says a helicopter on a joy flight over Kakadu National Park travels due east for 125 kilometres, then on a bearing of 215 degrees true for 137 kilometres before returning to its starting point. Find the total length of the journey correct to the nearest kilometre. So as I mentioned in the previous video, let's actually pick apart this question in a little bit more detail here. So a helicopter is on a joy flight. We don't care that the helicopter's on a joy flight. We do care, though, that it travels due east for 125 kilometres and then on a bearing of 215 degrees true for 37 kilometres before returning to its starting point. So they're the key pieces of information in this question. Now, what's the big question? We're being asked to find the total length of the journey. All right, so that find is my questioning word. That's how I understand what I actually have to do. And then I always like to highlight what's my level of accuracy, nearest kilometre. Okay, sweet. So let's actually start breaking this down. First thing I spot here, it travels due east. So as soon as they've given me a north, south, east, west, my brain straight away says, oh, bearings. That's the 360 degrees thing. That's the bird's eye view thing. So you might even want to just quickly jot yourself a north, east, south, west compass. Cool, I've got north, east, south, west. Just as your reminder, what is east? Which way is east? What are you talking about? Okay. Then what I would do next is I've got to start somewhere. So all I would do for my helicopter here, I'm just going to put a little dot on my page and say that's the helicopter. Rereading the information, my helicopter travels due east. And I can see from my arrow over here, oh, east is to the right. Cool. We're thinking bird's eye view, looking straight down at this helicopter as it travels east. It's going to go across like this. And it travels for 125 kilometres. And it gets to the second point on its journey. Let's give that a name. Let's just call it B. Why did I call it B? I have no idea. I just did. Right. The next thing. It then goes on a bearing of 215 degrees true. So we've got a bearing. And it's going on a bearing of 215. So I want to find out the bearing at this point B. Now, if I ever want to find out bearings at a point, what I do at that point is I just draw that north arrow because my bearings always come from that north arrow. And then I can do a little bit of an analysis here. Again, we stop and we think, we take our time in this important point. And I say, right, well, if I went that far, I've gone 90 degrees. Well, I've got 215 is bigger than 90. If I went that far, I've gone 180 degrees. Well, 180 degrees is not as big. I've got to get to 215, so 180 degrees isn't big enough yet. If I went this far, 3/4 of a turn, I've gone 270 degrees. Right, now I'm thinking, hang on, I've gone too far, 270 degrees. So I know where 270 is. I know where 180 is. So I'm just going to make a line somewhere in between 180 and 270 and call it 215. And it goes on this bearing for 137 kilometres. And 137 is bigger than 125, so I've made that line a little bit bigger. Alright, and I know that that angle, 215 degrees. So I'm starting to build up my diagram. I've got some key information on here. After this point, I'm going to call that point C, just because the helicopter then flies back to its beginning. And there's my loop. I've got to find the whole journey. And I just noticed I called that degrees instead of kilometres. That was a bit silly. All right. So straight away here, there is no mention of right angle triangles. Okay, my diagram doesn't look like a right angle triangle. There's no mention of right angle triangles. I'm just writing this because I said I'm going to notate these videos. Takes me a little bit longer, but it might just help with your notes and your summary journal. So no mention of right angles. Don't use SOHCAHTOA. All right, unless you're sure there's a right angle triangle in the problem, don't use SOHCAHTOA. But we do have a triangle, so let's then assume that it is a non-right angle triangle. So I'm going to start, my brain's already going into a space where it's thinking sine rule or cosine rule. Okay, which one? I don't know yet. Because at the moment I've got two side lengths, but I haven't got any angles in my triangle yet. All right. So now what I do is I go into the analyze part. So I'm starting to go into my analyze and I'm thinking, what can I get out of this? What can I add to this diagram that I don't already have on there? So what can I add that I don't have already? And hopefully those people who know I work too slowly are screaming out at me, you can find the angle, you can find the angle. And absolutely, we can find the angle. And I gave you a hint before by saying that this line was 270 degrees round to this point. Because if I've got 215 and I've got 270, I can find out what that part is there. That angle has to be the difference between 215 and 270 degrees. All right, so let's work out what is the difference between 215 and 270 degrees. I might actually just leave that 270 degrees on the diagram. I'll put this 180 on the diagram. Sometimes it would be useful to find that angle in there as well, but in this case it's not, because that angle is not in my triangle. So I want to find the difference between 270 and 215. Let's write that down. And the reason I've written that down is I find the self-talk, getting that little voice in your head going, is a really powerful way of improving your understanding of mathematics. Find the difference between 270 and 215. And what I'm talking about with that little voice is as soon as you say the word difference, you should be thinking subtraction. Because difference and subtraction align in mathematics. So I'm going to actually do 270 minus 215 to get, I don't know, what am I going to get? 55 degrees. So this angle here has to be 55 degrees. Right. What do I actually need to find? So this is a good time to reread the question. What is the big question? What am I trying to do? I'm trying to find the total length of the journey. So I'm trying to find this total length. And then you go, oh, cool, I've got that side and I've got that side. So if I find out what this side over here is, I've got the total length. So let's actually write that on our diagram. Find this. Right, So I've built up my diagram. I've reread the question 3 times now as I've gone through. I've analysed what I already know and thought about what extra maths knowledge I can bring to help me. I've worked out I'm not going to use SOHCAHTOA because it's not a right angle triangle, but it is probably going to have something to do with the sine or the cosine rule. My brain's starting to feel pretty full. I've done a lot already on this question. So to help myself, I'm going to go back and I'm going to draw a really simple diagram. So I'm going to have 1, 2, 3 sides. I know that the angle here is 55 degrees. I know that this is 125 kilometers, and I know that this is 137 kilometers, and I want to try and find out this length over on this side. And it's about that point you should be starting to think, right, non-right angle triangle, sine rule or cosine rule. And our strategies for sine rule or cosine rule, sine rule, is there a butterfly? So those people who have been in class and listening will know what I'm talking about with the butterfly. And that would be, okay, can I create this nice little kind of butterfly thing going on? I've got one pair here. I don't have any other pairs of information. So I can't create, sorry, my screen just moved there. I can't create a butterfly. Doesn't work in this case. So I'm not going to use the butterfly method in this space. It's not sine rule. So no, didn't work. Then that leaves me one other option, cosine rule. But let's just check what was our method for identifying if it was the cosine rule. If I have something to do with 3 sides and 1 angle, then it's a cosine rule. I've got 3 sides that I'm working with and an angle, so it's absolutely the cosine rule. So how do I work with the cosine rule? Well, let's start by actually writing it out. We've got c squared equals a squared plus b squared minus 2ab cosine of c. Alright, so let's label our sides. We want to try and find x over here. So if I make that the c value, I'm going to go, let this be c, so then that's capital C. Let this one be a, and let this one be b. And it doesn't matter which one you make, a or b. Won't change a thing. Substitute, so c is x, a is 125, b is 137, 2 times 125 times 137 times cos of 55 degrees. Oh, my screen's jumping around on me, I don't know why. We'll deal with it. Once I get to this stage, it's just a matter of putting that into your calculator. So right now, off the side of the screen that you can't see, I am literally typing out what is on the screen, and hopefully I don't make a mistake as I try to talk and press buttons on the calculator at the same time. And I get 14,749.00705. Now this is a great point to just indicate notation in maths can help us. So by not being lazy, I can actually remind myself that this isn't what I'm trying to find. This says x squared and I'm trying to find out what x is. So by keeping that notation and continuing to write it, it reminds me, oh, I don't want to have that squared there. I only want the x. How do I get rid of a squared? I take the square root. So I want the square root of my answer. Again, back to my trusty calculator. And that gives me, sorry, I'll just write that out again. You wouldn't need to show that step on a test that I've just written. I have just shown it because that's what I was writing as I was talking. Okay, so go back to the question. Make sure you've answered the question. My question is find the total length of the journey. Did I find the total length of the journey? Is this 125 the total length of the journey? Absolutely it is not. So total length will be equal to 125 plus 137 plus 121.45. I don't know why I wrote 125 over there. That was a bit silly. 121.45. Again, back to my calculator, add them all up. 125 plus 137 plus 121.45, and we get 381.3. And it tells me, I highlighted it to the nearest kilometre, so it's 383 kilometres. And that's the end of the second video. Hopefully there's some notations and ideas there that help you work through these problems on your own.